All right, last homework problem for Friday. Page 129, problem number 18. This one was in section C, which is the hard challenge problem section. And honestly, I would have been quite impressed if you got this answer by yourself. So don't feel bad if you weren't able to get it. But we're going to go through it together here on this video, and hopefully it will make sense to you. All right, let's read the problem. It says, Natalie has some nickels, Dirk has some dimes, and Quincy has some quarters. They're making use of alliteration there. N, N, D, D, Q, Q. So at least it's easy to remember who has what type of coin. Dirk has 5 more dimes than Quincy has quarters. If Natalie gave Dirk a nickel, Dirk gave Quincy a dime, and Quincy gives Natalie a quarter, they will all have the same amount of money. How many coins did each have originally? I've gone ahead and created 2 charts. Unlike most of the problems that I've done on the videos, I've done most of them on the fly. This one I actually sat down and had to think about. So as I'm explaining this to you, it may seem like, oh, she's just easily doing that. Yeah, but I've already looked at the problem before. So don't feel bad if it didn't come to you this easily. I made 2 charts because I want the first chart to be for what they had originally, and I want the second chart to be for what they had after they gave a coin to someone else. So originally and after giving a coin. Oops, I don't know why I put a T there. All right, so we've got Natalie, Dirk, and Quincy. Okay. Let's talk about the original situation first. We need to know the number of coins they had. Okay, we don't need this. We've already used this sentence. Natalie has some nickels, Dirk has some dimes, and Quincy has some quarters. So I'm going to scratch that sentence out. We've used it. Dirk has 5 more dimes than Quincy has quarters. All right, we don't know how many quarters Quincy has, so we're just going to say Q. And if Dirk has 5 more dimes than Quincy has quarters, then Dirk has Q plus 5. So we've now used the second sentence. It doesn't tell us anything about how many nickels Natalie has. It just says if Natalie gave Dirk a nickel, if Dirk gave Quincy a dime, and if Quincy gives Natalie a quarter. They all have the same amount of money. How many coins did they each have originally? So we don't know. It never told us how many nickels Natalie had, so we're just going to put N. Now, on this later chart, after giving a coin, we're still going to need to know the number of coins. But this time it's going to be changed because Dirk gave a nickel. Dirk gave Quincy a dime, Natalie gave Dirk a nickel, and Quincy gives Natalie a quarter. So everybody's given 1 of their coins. So if in the second chart I want to know the number of their coins, and I'm going to circle their coins because this is the number of nickels, this is the number of dimes, this is the number of quarters. I know that they'll have 1 coin of a different type, but how many do they have of their type? If everyone gave up 1 coin, then all of these values will be -1. So Natalie would no longer have N nickels after she gives away a coin. She would have N minus 1 nickels. And Dirk would no longer have Q plus 5 nickels. He'd have Q plus 4 nickels. because 5 minus 1 gives you 4. Quincy would no longer have Q quarters. He would have Q minus 1 quarters. Hopefully you're with me so far. All right, back to this first chart, talking about the number and value that they had originally. In this column, we're going to put the value of the coin. And I'm going to use units of cents. That way I don't have to deal with decimals. All right, Natalie had nickels, and nickels are worth 5 cents. Dirk had dimes. Dimes are worth 10 cents. Quincy had quarters, and quarters are worth 25 cents. Okay, on the first chart, last column, we're going to put the total value. To get the total value, you're going to take the number of coins they have and multiply by the value of each of their coins. So right here, I'm going to get 5n. Right here, it's 10 times all of that. So I'm going to use parentheses. So I'm really going to have to distribute. 10 times q is 10q. Keep your plus sign. 10 times 5 is 50. Okay. 25 times q is 25q. So our first chart is filled out. Go into your second chart. Let's put value of their coin. One coin. So for Natalie, she has nickels. It's still 5 for Natalie. Dirk has dimes, still 10. And Quincy has quarters, still 25. So number of coins they have of their type, value of their coin. If I multiply those two, this column is going to be the total value of their type of coin. Now I realize they're also going to have one coin of a different type, but this column is going to be value of their type coin. I'm going to circle their type coin because we're going to have, each person is going to have one coin of a type that's not their type. So you're still going to multiply the number of coins times the value of the coin. 5 times n is 5n. Keep your minus sign. 5 times 1 is 5. Again, 10 times all of that, so you're going to have to distribute. 10 times q is 10q. Keep your plus sign. 10 times 4 is 40. Okay? Again, you're going to have to distribute because it's 25 times all of this. 25 times q is 25q. Keep your minus sign. 25 times 1 is 25. Now, this is just the value of their type of coin. But remember, everybody was given an additional coin of a different type. So for this column, we're going to put the value of the coin given to them. Okay, value of the coin given to them. All right, what was Natalie given? Well, actually, let's just read the sentence and fill it out from reading the sentence. If Natalie gave Dirk a nickel. Okay, so Dirk was given a nickel. So Dirk, if he was given a nickel, he was given a value of 5 cents. Okay, so we can scratch out this part. Dirk gave Quincy a dime. All right, Quincy was given a dime. So Quincy was given a value of 10 cents. So now we can scratch out that part. And Quincy gives Natalie a quarter. All right, Natalie was given a quarter. So the value given to Natalie for that last coin was 25 cents. So this column is the value of their own type of coin, and this column is the value of the type of coin that they had given to them, and they just had one given to them. So if you put the value of their coins plus the value of that one extra coin given to them, if you add these two together, that's going to give you the total value that they have. Okay? So 5n minus 5 plus 25 would give you 5n plus 20. 10q plus 40 plus 5 would give you 10q plus 45. 25q minus 25 plus 10 would give you 25q minus, oops, not 25, 15. Because negative 25 plus 10 gives you negative 15. Okay, so now going back to our paragraph, we can cross out that part. Now the next part says they will all have the same amount of money. This column is representing the total value that each person now has, both from their own coins and the extra coin they were given them of a different type. So if they all have the same amount of money, what we can say is this box is equal to this box, and this box is equal to this box. Or in other words, 5n plus 20 equals 10q plus 45 equals 25q minus 15. We've actually got a three-part equation. First part, second part, third part. Now remember, if you have one equation, you can only solve for one variable. If you have two equations, you can only solve for two variables. So what we'd like to do is, all right, we're not even going to look at that right now. This part by itself is a perfectly fine equation. You've got an equal sign, and you've got two sides. And notice that if I only use this box and this box, because remember, it says they all have the same amount of money. Well, that means Dirk, his amount of money is the same as Quincy's amount of money. Notice this is using the variable q and only the variable q, and this is also only using the variable q. So now you've got one equation and one variable. You can solve for q with this. Get your like terms together. So subtract 10q from this side. Seesaw principle says if you do it to one side, you have to do it to the other. So now you have 45 equals 15q minus 15. Take this 15 to the other side by adding it, because you're undoing the subtraction. 45 plus 15 gives you 60. This is 15 times q. To undo multiplying, you're going to divide. Your 15s cancel, because it's really 15 over 15, which is 1, and 1 times q is just q. Think of a clock. 60 minutes divided by 15 minutes would give you 4 sections of that clock. Sometimes thinking of a clock helps you do the math faster. So now we've come up with q equals 4. So go back up here. This box was 4. This is q plus 5. If q is 4, this is 4 plus 5. So this is 9. So we have figured out 2 out of 3 parts of the question they were asking. They said how many coins did each have originally. Dirk originally had 9 nickels, and Quincy originally had 4 quarters. We still have to figure out the number of dimes for Dirk, quarters for Quincy. I hope I said that right the first time. Now we have to figure out how many nickels Natalie had. Okay, remember, all 3 pieces are equal. This box equals this box equals this box. So I need to now work with the box that has n involved. I could set it equal to this box, or I could set it equal to this box. I'm going to choose this box just because I'm not dealing with a minus, and I'm also dealing with 10, which is easier in my head to multiply than 25. So my new equation, I'll just do it right here, is going to be 5n plus 20 equals 10q plus 45. Now we just solved for Q. Q was 4. So 10 times Q is 10 times 4, or 40. Simplify. 40 plus 45 is 85. Okay, subtract 20. So we have 5n equals 65. Divide by 5, both sides, to get n by itself, and you get n equals 13. So go back to our original chart, and now you have all three answers. Natalie had 13 coins, Dirk had 9 coins, and Quincy had 4 coins originally. That's it.